The materials for this lab include a sodium bicarbonate and sodium carbonate mixture, a ring stand, a Bunsen burner, metal gauze, a crucible and cover, crucible tongs, a clay triangle, a balance, a striker, and a spatula. Remember to always wear safety goggles, an apron, and gloves. Step 1. Set up a Bunsen burner with a ring stand. Place the Bunsen burner under the ring clamp. Mask the empty crucible and cover on the balance and record. Using a spatula, add the sodium carbonate and sodium bicarbonate mixture into the crucible. Then mask the crucible with the mixture in it. Place the clay triangle onto the ring clamp, then place the crucible so it fits into the clay triangle. Place the cover onto the crucible so that there is a slight opening. To light the Bunsen burner, turn the gas switch and then use a striker once the gas switch is on.
Okay.
Allow the Bunsen burner to heat the crucible for at least 8 minutes and then turn the Bunsen burner off. Using tongs, remove the crucible from the clay triangle on the ring clamp. Then place the heated crucible onto metal gauze to cool. Allow the crucible to cool for at least 10 minutes. Mask the crucible and cover after the first heating after it finally cools. Place the crucible and cover back onto the clay triangle for a second heating. Turn the gas on again for the Bunsen burner and then light the Bunsen burner with a striker. For the second heating, allow the crucible to heat for 5 minutes.
Okay.
Turn the Bunsen burner off.
Yeah.
Then, using tongs, remove the crucible from the clay triangle and onto the metal gauze. Allow the crucible to cool for at least 10 minutes. Mask the crucible and cover after the second heating and record. Repeat this process for a third heating. Mask the crucible and cover for the third heating and record.
When looking at the data table, your first step is to subtract the mass of the crucible and lid from the mass of the crucible, lid, and total mixture to find the mass of just the mixture of sodium carbonate and sodium bicarbonate. Repeat the previous step, but this time subtract from the mass after the last heating to find the final mass of the contents, which at this point should just be sodium carbonate. Subtract the ending mass from the starting mass to find the difference. This difference, as seen by the decomposition reaction of sodium bicarbonate, represents the mass of carbon dioxide and water lost to the air in their gaseous states. Because we're still working with mass, the next step is to use the mass ratio of 1 mole of carbon dioxide to 1 mole of carbon dioxide in water. So this is the molar mass of carbon dioxide over the sum of the molar masses of carbon dioxide and water. Multiply this by the calculated mass of carbon dioxide and water from the last step to find the mass of just carbon dioxide. Next, convert the mass of carbon dioxide to moles by using the molar mass of carbon dioxide. Knowing the number of moles of carbon dioxide produced by the reaction, it is now possible to find the number of moles of sodium bicarbonate by referencing the decomposition reaction of sodium bicarbonate once again. This will show us the mole-to-mole ratio within this specific reaction. Multiply the moles of carbon dioxide by the coefficient of the sodium bicarbonate over the coefficient of the carbon dioxide to find the number of moles of sodium bicarbonate. Then use the molar mass of sodium bicarbonate as a conversion factor to find the mass of sodium bicarbonate in the starting mixture. Now, to find the percentage of sodium bicarbonate in the starting mixture, divide the mass of just sodium bicarbonate by the total starting mass of the mixture, then multiply it by 100. Alternatively, in step 4, you can convert the mass of carbon dioxide in water to the mass of water instead of converting to the mass of carbon dioxide. All of the steps would remain the same, but you would simply substitute the values for carbon dioxide with those of water.